call out and say, hey, I have a question, and let me know. Okay, so this is about the production possibilities curve. You'll notice throughout this course that so much as we use models, right? Graphs. Your FRQ, for example, if you have to write 50 words, that would be a lot, right? It's all drawing graphs and things like this. And so this is the first of the really important graphs that you need to know. Fortunately, this is a really easy one that everyone pretty much nails. You can see from the cartoon, you can see the trade-offs that these ladies are going through there, okay? So basically what the production possibilities curve does is it represents the concept of trade-offs and opportunity costs through a graph, right? It uses a model to show those concepts. So as we said yesterday, a trade-off is anytime you have a choice between two alternatives. I can do this or I can do this other thing, okay? You may have lots of choices, but at the end of the day, you get down to one or the other, okay? And then the opportunity cost is what you give up when you make that choice, right? So if you make the choice, if we think back to those ladies on the first screen, if they make the choice to kind of go out and eat and have fun, and what are they giving up? They're not going to be able to look at themselves in the mirror and put a bathing suit on and go to the beach, okay? At least those ladies, right? Hopefully we all don't care and we just go have fun anyway. So let's look at this cartoon here. You have a guy laying in the hospital bed, and he says, still, you want to admit it was fuel efficient, right? So just think to yourselves, I'm not going to ask you to call out necessarily, but think about the trade-off that this person in the car was going through, right? Well, he could get a fuel-efficient car, or he could get a car that was safe, all right? He obviously made which decision? He made the decision to get the fuel-efficient car, okay? And so what is the opportunity cost? Well, he missed out on being safe, and here he is in the hospital all messed up, okay? And so that's just a quick review of opportunity costs and trade-offs. Now, let's look at how this stuff is represented on a graph, okay? So when we draw it's called the production possibilities curve. Sometimes you'll see it referred to as a production possibilities frontier, right? It's all the same thing, but we make 4 assumptions when we look at a production possibility curve. The first is we're looking at a snapshot, okay? We're looking at one particular moment, right? Resources are fixed, the type of resources, the amount of resources, okay? So we're going to assume that that's not going anywhere. Technology is constant, right? So we're not going to be, ramping up technology. Whatever we have at that moment that we're looking at the curve, that's fixed. We're only looking at 2 types of products. Obviously, economies produce many products, but we're only assuming that they produce 2. And then finally, all resources are being fully employed. Everybody that wants to work is working. They're being efficient. No one's sitting around doing nothing, okay? And so just kind of keep those in the back of your mind. So here we have a chart on the left and then the actual production possibilities curve on the right, right? And all you would do if you're asked to plot points, very rarely are you asked to plot points, but I think you guys are able to do that, right? 0 goes where the X and Y axes meet, right? And you go up one side and across the other. And so, if this economy is producing 100 bulldozers, they're not able to produce any pizza, and so on and so forth. And we'll talk about this here on the next slide. Don't worry about copying this down. You will have tomorrow, you'll have examples of being able to copy this. I just wanted to give you a chance to show you what it looks like. Or you can go back if you need to put it in your notes or something. But you'll have plenty of time to do this tomorrow. So let's look at the things that the production possibility curve tells us. You see 3 points there. Okay, and so we'll talk about those. So points on the curve. Any point on the curve represents efficient use of resources. The economy is working to its potential. Okay, so if they're operating on the curve, they're using their resources in the best way possible. There is not a single point on the curve that is better than another point, okay? Unless we talk about allocation, which I'll mention in a minute. So you could put that E all the way up here to the 200, okay? You could put it way down here to 100, or any point in between. All of those represent efficiency, okay? Any point inside the curve tells you that they're being inefficient or they're underutilizing their resources. Because if you look at this here, right, if you look at the eye, they're producing 80 pizzas. Well, if they're producing 80 pizzas, right, they should be able to produce somewhere, if you look, maybe like 80 bulldozers. But they're only producing 20. So something is happening where they're not able to use their resources to their maximum. So any point inside the curve tells us resources are being underutilized, they're not being used correctly, and the economy should be doing better. And then a point outside the curve tells us that this point is unattainable, and this is the key, under the current conditions. Okay? So in that snapshot that we talked about a minute ago, okay, they can't produce at point U. Right? If they're producing 200 pizzas where that looks like, right, they should be able to produce no bulldozers, right, because they don't have the resources. But what are they doing? They're producing 100 bulldozers. Scarcity tells us that's not possible. Their resources are limited. Can they get to that point? Eventually they could, and they would like to, right? They would like to get to that point, and we'll talk about tomorrow in the next couple days ways to get there. Okay, so again, all points along the curve are efficient. Okay, and then we talk about allocatively efficient. Okay, now let's just pretend that this was an economy made up of college students. Okay, would it be allocatively efficient if they put all their resources to making bulldozers? No, that wouldn't be smart, right? That's not what college kids want. College kids, and actually some high school teachers, want pizza, right? So if you're going to allocate your resources efficiently, you want to put it to pizza, okay? So if they put it towards bulldozers, they're still being efficient in production, but they're not being efficient allocatively, okay? Hopefully that makes sense. And then, let's look at opportunity cost. Don't worry about that down there at the bottom. I was messing around and I couldn't figure it out, so don't worry about it. So let's look at opportunity cost. What's the opportunity cost of producing the first 20 bulldozers? So if you're making 0 bulldozers, you're making 200 pizzas. If you say, you know what, I want to make 20 bulldozers. So when you move to that point along the bottom at 20 bulldozers, what did you have to give up? Well, now you're over here, so you have to give up 40 pizzas. And so that's how the opportunity cost is shown on the production possibilities curve, right? Again, we'll practice this tomorrow. You'll be able to see it. You guys will get it really quickly once you go through it a few times. Okay? Let's look at another one. What's the opportunity cost of producing the next 20 bulldozers? So to go from 20, they're producing 160 pizzas. When you go to 40 bulldozers, it looks like maybe they're producing 120 pizzas. So now you're going to another 40 pizzas you're giving up. And again, the opportunity cost is what you give up when you make a decision. So when you decide to make 20 bulldozers, you're giving up pizza. All right? And so you can see every time this economy produces 20 more bulldozers, they must give up 40 pizzas. Or, if you want to reduce that down, for every bulldozer, they give up 2 pizzas. Okay? And to gain 40 pizzas, we give up 20 bulldozers, or you just inverse it, right? If we give up 1 for 2, then 1 would be 1/2 if we phrased it the other way. Again, we'll talk about this tomorrow and when we get into comparative advantage on Friday, but that's the idea. This is a constant opportunity cost, right? The straight line says for every one, I'm giving up the same amount. It doesn't change. Let's look at economic growth here, okay? Economic growth is represented by, okay, a movement outward of the production possibilities curve, right? And it's possible that some parts of the economy grow faster than others, okay? So if you look at this example, and this is actually, I guess, something that actually happened, right? In this period of time, we were able to grow corn faster than we were for wheat. And so if you look at the production possibilities curve from 1950 to 1975, if you notice, it goes up a little more here than it does here. So we were more productive in corn than we were with wheat. And then from 75 to 2000, again, look at us growing more corn, maybe the technology, the soil, whatever it might have been, allowed us to grow more corn than wheat. Okay? And law of increasing opportunity costs. Okay? We just talked about constant opportunity costs. Let's talk about increasing opportunity costs. Okay? If every time I make a decision I have to give up a little bit more of the other product, that's going to be called increasing opportunity cost. Okay? This is an important idea. We're not talking about prices. We're not talking about money. We're not talking about, well, bulldozer. I can sell a bulldozer for more money than I can a pizza. This doesn't take pricing and sales or anything into effect. We're just talking about product, okay? We're not talking about the dollar value, okay? And so the more of a product is produced, the greater its marginal opportunity cost. And we'll look at an example here in a minute, right? And so the slope of the curve that shows increasing opportunity costs, the curve will bow rather than stay straight, right? It'll be concave. It'll look like someone took it and was like pulling it out. It'll look like an arc, like an actual curve, really. All right, so let's take a look at this. All right, so there you can see our same example with pizza and bulldozers, right? But you can see that the opportunity cost, or the curve, is actual curve. So let's explain why this is the case. So when we go from point A to B, right, we're deciding to make more bulldozers, right? So imagine that you've taken all the people in this community that make pizza, and you've taken the best pizza maker. We're going to call him Mr. 01. I don't know if you've had that pizza. This used to be Papa John until Papa John became a racist. And so I took him out of my PowerPoint, that'll show him, and made it Mr. 01. So Mr. 01 is the best pizza maker, and you got the worst pizza maker at the end. So what do you think you're going to do when you start making bulldozers? Which pizza makers are you going to get rid of? You're going to get rid of the worst pizza maker, okay? And so you send your worst pizza maker over to the bulldozer factory. Well, if he's not very good at making pizzas, right, you're not going to lose very much pizza. He wasn't so good at it anyway, right? And so, by sort of definition, if he's the worst at making pizza, he's probably going to be the best of those guys at making bulldozers, okay? And you can see this will happen all the way down the line, right? So I can gain a lot in bulldozers without costing me very much pizza. But what happens is you start to go down the line making bulldozers. You're starting to get rid of your best pizza makers. Each one you get rid of is better at making pizza. So as you start to make more bulldozers, you're giving up more pizza. Until what happens at the very end, you let your best pizza maker go, and now you're all the way down to zero. Okay? That's the law of increasing opportunity costs. Okay? When the resources aren't exactly, they're not transferable between each other. Okay? And so, you see at the very beginning you give up very little, and then as you move closer towards the end, you give up a lot, all right? And Anytime you hear increasing opportunity cost, it's always going to have that bowed look to it. And constant opportunity cost will always be that straight line. And then this last one, I don't even know what this is. Oh, so C to D. When you send Mr. 01 to the factory, you gain very little in bulldozers because Mr. 01 is good at making pizza. He's not very good at bulldozers, so you're not gaining much in bulldozers, but you're losing a lot of pizza. Okay, and so you lose a lot of pizzas. So a small gain in bulldozers comes at a high opportunity cost in pizza.